Alright, in this video we're going to be looking at Quartic graphs. That is a polynomial that has an x to the power 4 term. So let's see what one of those looks like. So it's got an x to the power 4 term. So a term that looks like this will be the sort of polynomial that we're looking at for a Quartic graph. Power 2 plus there you go. So you can see that it's got an x to the power 4 term. Now, similar to a cubic, this can also be factorized, but this time it will be factorized into 4 factors. So something that looks a little bit like this. Now, let's just do an example, and you'll see that it's quite similar to cubic graphs. So let's do the example where this Quartic is x minus 1 times x minus 2 times x minus 3 multiplied by x minus 4. So here you can see that if you multiply the first term, all the first terms together, you'll get an x to the power 4 term. So you know that it is a Quartic graph. So let's go ahead and sketch that graph to see what it will look like. And whoops, here it is done for you. So here you can see that same equation that I've got, and here's the general shape of the graph. So there we go. Now we can notice a few things about it. Firstly, it starts off as highly positive over here, and it has 1, 2, 3 turning points, and then goes back up. So this one is symmetrical, 3 turning points. Well, it maybe won't be symmetrical soon, but it starts off highly positive and has 3 turning points. So it looks a bit like, looks a little bit like a W, if you like. Whoa. There we go. Now let's consider some of the other graphs we've done. We've done just linear graphs, so ones that just have an x term, and they start off negative and have no turning points. So they start off in this sort of third quadrant, have no turning points. Then when we had an x squared term, it looks like this. 1 turning point starts off highly positive. Then if we've got an x power 3 term in it, then it will look like this. So we've got, starts off negative again, 2 turning points. And then this one we've just discovered now, with the Quartic, starts off highly positive and has 3 turning points. So you can sort of see the pattern here: 0 turning points, 1 turning point, 2 turning points, 3 turning points. And the other pattern starts off in the negatives, starts off in the positives, starts negative, starts positive. So you can sort of already imagine what the x to the power, what a quintic would look like. It will start off in the negatives, because that's the next one in the pattern. So up in the negatives, and here we had 3 turning points, so this one will have 4 turning points. So you can just sort of 1 turning point, 2, 3, 4, and it will look something along this sort of lines, if you like, for an x to the power 5 term. So this pattern can be a very helpful way of remembering what's going on. Now let's think back to our example here. In this factorized form, using the null factor law as per usual, we can find the x-intercepts. So we know the x-intercepts will be at x equals 1, because that's when this is going to go through the x, when that term is going to be 0, or x equals 2 for this one, or for this one it's going to be x equals 3, and for this one it's going to be x equals 4. So let's go back to our graph and see if that is indeed the case. So yes, cuts through at 1, 2, 3, and 4. Okay, so now I might change this equation a little bit. So I'll change this term from x minus 1 to, say, maybe I'll make it here, over here, so it's x plus 1. So now it'll cut through at x equals minus 1. There it is, x equals minus 1. And you can see that the graph is no longer symmetrical. So this will not necessarily be a symmetrical graph, so it goes all the way down, somewhere. So there we go. So let's put that back to, I'll make it 0 perhaps. 0, so now it cuts through at 0 because this term's just x. So we can play around with that if we want. Now what I'm going to do is I'm going to move this intercept so that it's also on 2. Okay, so I'm going to change this term with just x. So now it's x minus 1. I'm going to make it x minus 2. So there's 2 x minus 2 terms in there. There we go. So now there are 2 terms in x minus 2. And so what that means is this only just touches this point here. Only just touches it. Now what happens if I change the x minus 3 to x minus 2 as well? So from 3 to 2. So now there are actually sort of like 3 points here. They're all there. So because there are 3 points there, it doesn't come up anymore. It's a point of inflection now, and it goes back down. So that's when there's 3 x minus 2 terms. Now if I wanted to, I could put the 4 onto the x minus 2 as well. There we go. So now all 3 of the turning points are right there. So you can, so because there are 3 turning points, it's like it turns around once, meaning it'll come back up, but then it'll turn around the second time, go back down, and then the third time, come back up again. So you can kind of, because there are 3 turning points sort of all in the one spot, it'll go back up is the final result. So back when we had, here we've got 2 turning points. So the first turning point makes us want to go up, and then the second one makes us go down. So overall we've got it down because it's whatever the second one was. So there we go. Let's head back here. So that's basically the majority of what you need to know about these Quartic graphs. The only other thing that's worth knowing is if there's is we can write it in sort of an equivalent to turning point form if we can get it to look something like this. If it will look if we can get it into this form, or there might even be a factor of a at the front. If you can get it to look like that, what that's going to mean is the overall graph has all of the turning points in the same spot, and it will kind of look like that one we had there, where it's a bit flatter along the base compared to a quadratic. It's flatter along the base. Oops. But then it eventually, so it's flatter along the base, but then it's much steeper in these curves. So I could show you a quadratic along with a quartic. I think that would be helpful. So where are we? So let's get rid of that graph that we had, and we'll get rid of these. Okay, so here, oops. Here's a standard quadratic, x squared. There it is. So you're very familiar with that sort of thing, a quadratic. And now we'll put in a quartic, x to the power 4. And you can see the difference here. So it's the quartic, it's flatter along the base. They cross over at x equals 1 and minus 1, here and here. And then the quartic becomes much, much steeper, or larger values are occurring for that. Now, just for fun, we could also plot an x to the power 6 graph in there. So when we do the x to the power 6, it's got the same sort of behavior again. So the x to the power 6 graph is even flatter again than the x to the power 4. It still crosses over at minus 1 and 1, and then it goes even steeper again compared to the quartic. So that sort of pattern will continue happening if I go into then the next one will be x to the power of 8. There we go. So I think that's where I'll leave this video. Good luck to you.